and welcome, and in this video we're going to be talking about the transformations of the absolute value function. So before we jump into that, I just want to make a note that the way we transform the absolute value function is actually going to be the exact same way we transform every function throughout our mathematical journey, okay? So we are going to be transforming absolute value functions this way: quadratics, square roots, logarithms, trigonometric functions, all of them. They all are affected the exact same way using the exact same kind of parameters. So before we talk about transforming the absolute value function, we have to talk about something called the parent function. We need to talk about something called the parent function. Now, the parent function is just the most simplistic form of that particular function. So the most simplistic absolute value function would simply just be y equals the absolute value of x. Simple. There's nothing really to it. Now, the way we transform that is by doing a couple different things to the absolute value function. We could multiply a number out in front of the absolute value function. We could add or subtract some number outside the absolute value function. We can even add or subtract some numbers inside the absolute value function. And there's actually one other one. You can multiply within the absolute value function. That would be another kind of special color there. But things get a little bit tricky once we talk about those, so we are going to save that particular one for a future function. But just know that a, h, and k are just going to be actual numbers like 2 or -3 or 17. And we will use these numbers the exact same way once we talk about other functions. So I want to first take a look at how the value of h, when we add or subtract inside the absolute value function, I want to take a look at what that does to the graph. So let's go ahead and take a look at that. So what I have here is our parent function graphed in black, and I also have our transform function in red. Now, right now, we haven't done anything to it yet, so that's why they lay on top of one another. But I'm going to start messing around with this value of h. So notice, as we are adding or subtracting some number inside the absolute value, see what happens. It moves horizontally. It is moving left and right. It's moving left and right. So that is exactly what happens when we add or subtract inside the absolute value function. We move the graph left and right. So let's go ahead and write that down. So that moves the graph horizontally, but we need to be able to determine which way it is going to move. Is it going to move left or is it going to move right? So let's take a look at that. Let's go ahead and go back to our graph real quick. Now, let me go ahead and get rid of this one real fast. Now, we need to be able to determine if it's going to move right or left. So I'm going to mess around and create two new absolute value functions. So we have x plus 2 inside the absolute value, and we have x minus 5 inside the absolute value. So what we need to be able to do is we need to be able to identify what is going on. So if we add 2 inside the absolute value function, we should be moving 2 in either the left or right direction. So if I go ahead and show this, you should see that it has moved 2 to the left. 0, 0 has now become -2, 0. The 0.11 has now become the point -11. The 0.33 has now become the 0.13. Okay, so everything got shifted over to the left too. So when we add inside the absolute value function, we actually move to the left by that many units. That might seem kind of weird. You might have expected it to move to the right because it is plus, but the original transform function, notice it is x minus h, so it actually kind of works the opposite of what you would think. Generally, anything that's going on inside the function, and by inside the function, I mean inside the absolute value itself in this particular problem, is going to affect the graph kind of the opposite way that you would normally think. Because normally you would probably go, well, x minus 5 inside, that would probably move to the left, but it actually moves to the right 5 units. So when we add inside the absolute value function, we move to the left, and when we subtract inside the absolute value function, we move to the right. So let's go ahead and write that down. All right, so as we add inside, we move to the left h units. So when we added 2, we move to the left 2. If I added 5, I'd be moving to the left 5. If I added 7, I'd be moving to the left 7. So that's what I mean by move left h units. Now, if I subtract inside, I actually move to the right by that many units. So I subtracted 5, I moved to the right 5 units. If I subtracted 1, I moved to the right 1 unit. If I subtracted 10, I moved to the right 10 units. So that's how the value of h affects the graph. When we add and subtract inside the function, we move horizontally, left and right. So now the next one I want to take a look at is k. The next one I want to take a look at is k. So let's go ahead and go back to our graph. Let's go back to our graph. And now I'm going to start messing around with the value of k. So that is adding and subtracting outside the absolute value function. As you can see, as we start adding and subtracting outside the absolute value function, we actually move horizontally. We move up, we move vertically. We just talked about horizontal. So when we add and subtract outside the absolute value function, we are moving vertically, up and down. But we need to be able to determine exactly how many units we're moving up and down and how to be able to determine that. So let me go ahead and get rid of this. And I'm going to change these two functions once again. I'm going to add 2 outside, and I'm going to subtract 5 outside. Now, once again, this is going to move the graph either up or down. So when I add 2 outside the absolute value function, not inside, outside the absolute value function, it moves up 2 units. So as you can see, everything got shifted up 2 units. So 0, 0 became 0, 2. 3, 3 became 3, 5. Negative 1, 1 became negative 1, 3. So everything got shifted up 2 units, and that's probably what you would have expected. And you would probably expect, well, subtracting 5 outside is going to move it down 5 units, and that's exactly what happens. So anything that's going on outside the absolute value function generally is going to work the exact way you would think it would. That's a tough. Why did I have trouble saying that sentence? Anyway, so when we add outside the absolute value, we move up that many units, and we subtract outside the absolute value, we move down that many units. So let's go ahead and write that down. So as we add outside, we move up k units, so we move up whatever that number is. If I add 2 outside, I move up 2. If I add 5 outside, I move up 5. If I add 17 outside, I move up 17, okay? Whereas if I subtract outside, I'm moving down that many units. So if I subtracted 2, I'm moving down 2. If I subtract 3, I'm moving down 3. If I subtract 17, I'm moving down 17, okay? Now, this actually brings up an important piece of information here. You've noticed that I've been saying inside the function and outside the function. That's because there's a nice little acronym I like to say that helps me determine exactly what type of transformation it is. Is it going to be a horizontal transformation, or is it going to be a vertical transformation? And that acronym is HIVO. So let me go ahead and kind of show you what I mean by that. So HIVO, and this helps me determine exactly what kind of transformations we are dealing with. Because as you can see, we moved horizontally when we added or subtracted inside the function. So all horizontal transformations are going to come from inside the function. All horizontal transformations are going to come from inside the function. So when I add, subtract, multiply, or divide inside the function, that is going to affect it horizontally, or the x-coordinate. However, anytime there was a vertical transformation, that is coming from outside the function. So all vertical transformations are coming from outside. They're coming from outside the function itself. So if I add or subtract outside, I moved up vertically. If I multiply or divide outside the function, that is also affecting it vertically, just in a different way. And I wanted to bring this up to you now because our last transformation we're going to talk about is what happens with a, the number out in front, multiplying. And things get a little bit more complicated there. So let's go ahead and take a look at that now. So now I'm going to talk about how this number of a affects the graph. So as we can see, it does quite a bit of a different thing. It doesn't shift it at all. It doesn't move left, right, up, or down. But what it does is it either makes it open upside down, it makes it a lot more narrow, it can make it a lot wider. That's how it affects the graph. But there's actual specific ways that we want to explain how it's affecting the graph. And this is going to affect it vertically each way because a is outside the function, and that affects the function vertically. Now, the first thing I want to note is that see, it only opens down. It opens down when a is negative. Notice when a is like negative 7.5 or negative 4.8 or negative 0.9, it is opening upside down. And what that is called is a reflection over the x-axis, okay? It has been reflected. It opens upside down. It gets reflected over that x-axis. And that only happens when a is negative. So that's a very, very important transformation. So I'm going to go ahead and write that down. So when a is negative, it is reflected over the x-axis. Basically what that means, it is going to be opening upside down as opposed to normally when it's opening right side up. Now the next thing I need to talk about is how do we determine if it's going to be a lot more narrow or a lot wider? And that determines on, or that all depends on what the value of a actually is. So let's go ahead and go back to our graph. Let's go back to our graph. And now what you should see is that when a is either a really, really tiny number like -8, -4.8, or a positive number like 4.4 or 7.2, it looks a lot more narrow. What we call this is a vertical stretch. So for example, if I had like a 4 here, it is being vertically stretched by a factor of 4. And what that means is that every single y coordinate is actually getting multiplied by 4, because the 0.11 became the 0.14. The 0.11 became the 0.14, if I can finally find it. The 0.33 becomes a 0.312. The -22 becomes -28. That's because every single y coordinate is getting multiplied by 4. So you are being vertically stretched whenever that whenever that number a is larger than 1 or less than -1. Because if this was -4, this is also being vertically stretched by +4. The negative only tells you it's being reflected over the x-axis. That's all the negative does. So if it's a -4, it's still being vertically stretched by 4. It's just also being reflected over the x-axis. Now, when that number is like a really, really small fraction or something like that, so say if it was like 1/2, notice it's a lot wider. If it was like 2/5, it's a lot wider, okay? If it was negative, say 3/10, it's a lot wider. So what happens here is if that number that is multiplying the absolute value is in between -1 and 1, another way of saying that is if the absolute value of that number is in between 0 and 1, it is what we call being vertically compressed, okay? Because say, for example, if I'm multiplying by 1/2, every single y coordinate is now being multiplied by 1/2. 2 becomes 2 4 becomes 4 8 becomes 8 4. So it is being vertically compressed. It's being compressed down, which gives it that wider look, okay? Whereas if it's being vertically stretched, every point is getting stretched out, giving it the more narrow look. So those are the last two transformations, and I want to go ahead and write those down. So when the absolute value of a is larger than 1, it's vertically stretched. So if a is like 7 or -10 or 13, that is being vertically stretched by that number. And if the absolute value of a is in between 0 and 1, so say like -1/2, +1/3, 2/5, -3/4, that is being vertically compressed by the absolute value of that number. So we need to be able to look at functions and determine exactly what their transformations are, and you can use these rules to determine that. So just for example, I'm going to go ahead and type out a function, and I can tell you exactly what the transformations are without even graphing it. So for example, if we had this equation here, we have 3 times the absolute value of x plus 1 and then -2. I can determine that the 3 is going to vertically stretch it by 3, the plus 1 is going to move it to the left 1, and the -2 is going to move it down 2. And if I were to graph that, that's exactly what I would end up seeing. So we need to be able to look at functions just like this one and determine what the transformations are even before we graph the function, and we will be graphing these functions using the transformations in the next video. So if there's any questions, please make sure that you let me know. I hope that this video was helpful, and I look forward to seeing you guys in the next video where we graph absolute value functions using these exact transformations.